Okay, students, let's go ahead and work through these problems. A lot of this deals with vocab from the beginning of the year. Which terms are demonstrated in this figure? Do we have a circle? No, we don't. Do we have an angle? Of course we do. Skew lines? No, remember, skew lines are three-dimensional. This flat surface is two-dimensional, so no skew lines. Parallel lines? Yes, we do. And the reason we can say that is because we have 90 degrees each there, which makes corresponding angles. And by the conversely corresponding angles postulate, we know lines M and N are parallel. Do we have a line segment? Yes, we do. AC or AB. Do we have perpendicular lines? Yes, we do. That's what perpendicular is, 90 degrees. Okay. Next. What's the best definition of line segment ST? It includes the points S and T and everything in between, all the points in between. Okay, are distinct points, which means they don't overlap, they're not the same point. JK, the length of JK equals KL. So let's say that's JK, and that happens to be KL. That means those are congruent, which these days must be true. Do they have to be coplanar? Yes. Remember, 3 points determine a plane, and we only have 3 points there. Are they collinear? No, they don't have to be. Here's an example of it not. Is K the midpoint? No, that would have to be collinear in order for it to be the midpoint. This segment is segment JK congruent to KL? Yes, it is. That means they're exactly the same length. The measure of JKL is 90 degrees. It does not have to be because it could be collinear. So it's just those two right there. Okay, so we have all that right there. And it's asking, based on the figure, which of the individual segments would provide enough information to conclude that, that little T there, line R is perpendicular to line P. Okay, so let's see where R is. Let's put R down here and right there. Okay, so that way you don't have to see the top part. Remember, if the name of the line can be by 2 points on the line or lowercase letter at one of the arrows. So that's why you see lowercase letters in R and P. Okay, so we're trying to conclude that R is perpendicular. That's 90 degrees to P. So in order for R to be perpendicular to P, angle 3 would have to be 90 degrees. Okay? Or angles 4 plus 5 would have to be 90 degrees. Either one. Okay? Or we'd have R and P here, 1 plus 2 is 90 degrees, or angle 6 is 90 degrees. So angle 6 is 90 degrees. Is angle at 2 about? No, it has to be 1 plus 2. Angle 3 equals 6. That's just vertical angle. That's nothing. 1 plus 6 is 90. No, 1 plus 6 being 90 would be N and P being congruent. 3 plus 4, 90. No, it's just 3 alone or 4 plus 5. And there's our 4 plus 5 right there. So those two. Okay. Oak Avenue runs directly north and south, so they're parallel. Okay. Which it says must be true based on the given information. Birch Street and Elm Street. Birch and Elm intersect at right angles. No, we don't know that. Maple Street and Pine Street are parallel. Yes, we know that. Conversely corresponding angles postulate. If more of the map is shown, Elm Street and Oak Avenue will not intersect. Yes, they will. Okay. Pine Street intersects both Birch and Elm. Pine Street intersects Birch and Elm. Yes, it does, there and there. Oak Avenue and Maple Street are perpendicular. Oak and Maple. Oak and Maple. Yes, that's true also. Okay. where the measure of angle A can range from 50 to 60, measure of angle B 90 to 100. Given these conditions, what's the correct angle measures for possible for angle C? Okay. So if we took the two smallest, 50 and 90, it's 140 degrees. So angle C, measure angle C would have to equal 40 degrees there. If we take the two largest, 100 plus 60 is 160 plus measure angle C equals 180. So measure angle C equals 20 degrees. So it's from 20 to 40. In an equilateral triangle, what's the difference between the sum of the exterior angles and the sum of the interior angles? Equilateral triangle, we know, is 60, 60, 60. And the exterior angle would be 120 degrees. So it says, what's the difference between the sum of the exterior angles? Sum of the exterior angles is always 360. Okay, no matter what polygon it is. Right, it's always going to be 360, just know that. And the sum of the interior angles, is 180 degrees. So that leaves you with 180. Okay. Measuring A and B are that, C is that, which expression correctly relates to the lengths of the sides of this triangle. So angle A is 95. Angle B is 50. Angle C is 35. Okay, well, we know the opposite, the angle goes along with the opposite side. So CB is the largest. So if we, this is going in order from smallest to greatest. So we're going to go smallest, medium, largest. The largest is BC. The medium would be AC. And the smallest would be AB. So that's what it should look like right there from smallest to greatest. AB, AC, BC, number 2. Okay, we have that figure. What's the total number of planes that are perpendicular to line M? Point P is on line M. What's the total number of planes that are perpendicular to line M and pass through point P? Okay, we've got that one. That is in that plane, but I could have there's only one there. Let's see. Okay, there's one in that plane, but it doesn't say it's got to be in a plane. So if I make this line P is it a line? Total number of planes that are perpendicular. Okay, not a line. Total number of planes. There's only going to be one plane that's going to come out. Directly to perpendicular line M and pass through P. Yeah, 1. Okay. We have this square here where the coordinates the midpoint of the diagonal LN. Well, I could go 1, 2, 3, 4, 5, 6, 7. So it's going to be 3.5 of these. 1, 2, 3. 1, 2, 3.5 right there. So what is that point? Here's 0, 0, the origin, -1, -2.5, comma, how far does it go up? 1, 2, 3, 4.5. there. Okay, side PQ of triangle PQR is extended through Q to point T. Okay, so triangle PQR says side PQ is extended through Q to T. And there's T's on it right there. Okay, which statement is not always true? Well, this is the exterior angle theorem, which then says that this angle equals this angle plus this angle. So the measure of angle X equals the measure of angle 1 plus the measure of angle 2. That's the exterior angle theorem. Okay. So the measure of angle RQT, which is our X, has got to be greater than the measure of angle R. Yes, that's true. Always. Angle RQT, which is X, is greater than P. Yes, that's true. Always. So we're looking for one that's not always true. RQT, which is X, equals P plus R. That's always true. So therefore, this one's one that's not always true. Okay. In a three-dimensional space, two planes are parallel and the third plane intersects both of the parallel planes. The intersection of the planes is a what? So I have two planes and a third plane intersects both of them. Okay. That's going to be another plane. So you take the intersection. No, parallel lines. Sorry. Parallel lines is what you're going to have right there. Okay, imagine a book and then a plane slicing through the book, top and bottom, would be two parallel planes. Based on the diagram below, which statement is true? Okay, well, we know this has got to be 120. So therefore, A, B, and C are not parallel to one another at all. Okay, this is 120 vertical angle theorem, which now makes this parallel to this. Okay, so we have that's true. So D is parallel to E. Converse of the corresponding angles postulate. Or you can say converse of the alternate AA, alternate exterior angles theorem. Okay, AB is congruent to AC. So we have a sausage triangle. The very first thing I should be thinking is base angles are congruent. The measure of angle B is 40, which makes this 40, it's 80. That makes this 100, called the vertex angle. Remember where the two isosceles or equal lengths come together, it's called the vertex. So that's the vertex angle. You got to know the name of that. Measure angle A is 100. The endpoints, segment C and D, what are the coordinates of the midpoint? Add the two x's divided by 2. That's 4 divided by 2 is 2. So that wipes out those two. And add these two. It's negative 2 divided by 2 is negative 1. See, there's your midpoint formula right there. One example of it. K, line K is perpendicular to plane P. Remember, one way of naming a P is a capital letter in one of the corners. And there's your plane. Otherwise, it's 3 non-collinear points. Remember, the definition of plane, at least three non-collinear points. All right, which statement is true? Any point in plane P is also on line K. No, there's a point that counteracts that. Only one line in plane P will intersect line K. That's true. All planes that intersect plane P will pass through T. No, that didn't have to happen. Any plane containing line K, is perpendicular. Now it can be parallel. Okay, number 2. Which set of numbers represents the lengths of the sides of a triangle? Remember the two smallest have to be greater than the third. The two long, that's 5 plus 13 equals 18. It has to be greater, so that wipes that out. 6 plus 17, that is greater than 22. So that's the answer. Here we have 7 plus 16 is only 23, not greater than 24. Here we have 8 plus 15 is only 23, not greater than 26. If two different lines are perpendicular to the same plane, if two different lines are perpendicular to the same plane, okay, they are not consecutive. The lines can't be congruent. They're different lines. So collinear means same line. So that's easy. So it's going to be in the same plane. Coplanar, same plane. Okay. The degree measures of angles ABC are represented by x, 3x, and 5x. Find the value of x. Well, we know all three angles add up to 180. So add them up to 180. So equal to 180. 4x, 9x minus 54 equals 180. 9x equals 234. Divide by 9 and you get 226. Basic right there. In the diagram below, we have an exterior angle theorem again, so that's 63. If that's 37 from 117 is 80, so that makes that 80 right there. Okay. Which side of triangle ABC is the longest side? So that's 80 degrees. The longest side has to be AC. Justify your answer. So you explain that right there and then say AC is the largest angle, therefore, angle B is the largest angle, therefore AC has to be the longest side. In isosceles triangle, ABC, AB, oops, so the one they have in common is B, so the vertex here has got to be B, A, and C. Which statement must always be true? This angle is congruent to angle A is congruent to angle C. A transversal intersects two lines. Which condition would always make the two lines parallel? Nope. Yes. Corresponding angles are congruent. Same side tangent angles are complementary. No, they're supplementary. Okay, so it's that one. In triangle PQR, PQ is 8, QR is 12, RP is 13. Which statement? So we're going largest to smallest in angle measure. So PQR, PQR, PQ is 8, QR is 12, RP is 13. So we're going largest to smallest. There's the largest, Q. So it wipes out those two. The medium is P. Puts it right here. Smallest is R. Remember, side lengths correspond with the opposite angles. Okay. In plane P, lines M and N intersect at point A. If line K is perpendicular to line M and line N at point A. Okay, so let's just draw this out. Plane P. Lines M and N intersect at A. If K is perpendicular to line M, if K is perpendicular to line M, NN at point A is perpendicular to both of them, then line K is contained in P parallel to plane P, perpendicular to plane P, skew to plane P. In order for it to be perpendicular to both of them, it has to be outside the plane, so it's got to be skew to plane P. Because in the plane, it can't be perpendicular to both of them in the plane. Okay. Perpendicular to plane P. That would be skew to plane P. Let's change this to perpendicular to plane P. Sorry. It's got to come straight down through the top, and it's got to be perpendicular in order to be perpendicular to both those right there. So it's got to be perpendicular to P, plane P there. All right, here's a isosceles triangle. This is the altitude, so that means this is a perpendicular bisector, which makes this equal to x, this equal to x. Okay, so that's the whole length is 2x. What's the length of the base? So now we have Pythagorean theorem. So we have x squared plus x plus 7 squared equals 13 squared. Okay, now it's algebra 1. X squared plus 14x plus 49 equals 169. I have 2x squared plus 14x. Subtract this across because it's a quadratic, so we said equal to 0. 49 minus 169 is negative 120. Now I can see they have a GCF of 2 in common, so we're going to divide everything by 2. Divide each term by 2. This is algebra 1 review. So I have x squared plus 7x minus 60 equals 0. And now I factor it, or use quadratic formula, or if there's a graphing calculator, just plug in the graphing calculator, and then set, that's the first equation, y sub 1, y sub 2, you make it equal to 0, and then do second calc number 5, intersect. If you had a graphing calculator on this, here this is going to factor into x plus 10 and x minus 3. That means x equals negative 10 there. You can't have a negative length. And that equals x equals 3. So there's my answer, 3. Oh, no, that's what x is 3. Go back to the length of the base, which is, that's 3. So total length is, 10 times, I didn't factor correctly. Dang it. Okay, so we have 12 times 5 is 60. So I have x minus 12, and x plus 12, and then x minus 5 equals 0. So there x equals negative 12, here x equals 5, and 5 and 5 is 10 for the base. We don't just want one side of it, we want the entire base. Okay, so you could also use quadratic formula into here, or plug that in a graphing calculator and y sub 1, y sub 2, y equals 0, and then do second calc number 5. Okay, and then you find the positive answer, which would be the 5. Oops, I missed some at the end here, I think. This last one here. In right triangle DEF, D is 90 degrees. and F is 12 degrees less than twice E. So let's say E is X, 12 degrees less than twice. So twice it minus the 12. We know these two angles have to be complementary because you already have the 90 degrees. So then this is 90 degrees to add up to the 180. So now I have 3x minus 12 equals 90. 3x equals 102 divided by 3, and I get 34. What did it say? Find E. E is just the x, so it's 34 degrees. Okay, if it's at F, I'd have to plug that 34 in there, or do 90 minus 34, and that would be 56. Okay. These are congruent, it says. Something's all, dang it, what just happened there? Okay. Which two statements identify corresponding congruent parts for these two triangles? AB, oh, let's go back up here. We just have to look at ABC is congruent, so I'll have to keep scrolling down, XYZ. Remember, just look at the congruent statement. AB goes to XY. That's true. Angle C is congruent to Y. No, it's not. C is congruent to Z. AB is congruent to YZ. No, it's not. BC is congruent to XY. No, it's not. BC is congruent to YZ, correct, and A is congruent to X, correct. Okay, that's just checking corresponding parts right there. Okay, they're similar. Remember, similarity means that the angles must be, corresponding angles must be congruent. The side lengths must be the same ratio. So if A is 50, C is 30, that's 80, that means B is 100. Since B is 100, then we also know X is 100. It corresponds. Which polygon does the sum of the measure of the interior angles equal the sum of the measure of the exterior angles? Okay. How about quadrilateral? Sum of the interior angles, each one's 90. 90 times 4 is 360. And of course, all exterior angles always add up to 360 no matter what the shape is. So quadrilateral. Okay, if a line simply has endpoints that and that, what are the coordinates of the midpoint? Add the x's together, divide by 2. That's 4x plus 4 divided by 2. Now add the y's together by 2. Oops. Add the y's. Why the heck did that not work? 3y minus y divided by 2. So I get 2x plus 2 here, comma, that equals 2y over 2, which is then y. 2x plus 2, comma, y is my answer right there. Okay, midpoint formula, just with algebraic expressions. Regular pentagon, remember I told you regular is going to be in there a lot. Regular is equilateral and equiangular. Okay, what's the measure of angle AEB? They want this one right here. Well, we know, since it's congruent, okay, and we know we can figure out that angle because we have the sum of the interior angles is n minus 2 times 180 divided by n. Okay, that's a formula you need to remember. Remember, n divided by n minus 2 times 180 is the total sum of the interior angles, and then we're dividing by n because it's all equiangular. So n was 5. So 3 times 180 is 540. Divided by 5 is 108. So A is 108. Well, now we have the base angle congruent. We can call that x and that x. So then we have 108 plus 2x equals 180. 2x therefore equals 72. X equals 36. Okay, so You got to remember your rule for sum of the interior angles, regular polygon, and then you're dividing by that same number to figure out each angle. That means each of these is 108 all the way around. The whole thing here is 108. Okay. In the diagram below, here we have the exterior angle theorem. This equals those two add together. Okay, so we have to do that first. 6x plus 20 equals 5x plus 35. So subtract that across, x, subtract that across, 15. X is 15. It wants QPT, this angle right here. So we're now filling that in. 6 times 15 is 90, plus 20 is 110 degrees. All right, we made it through it all. 31 minutes.